GenAI for DevOps engineers, 30 days, real labs, real workflows. Launch price, $39, limited seats. This program is built to fix exactly that. Not theory, not buzzwords, not build chat. We focus on practical GenAI skills that directly map to real DevOps workflows. This is not a video-only course. You'll get guided, hands-on labs, real environments, time-bound, controlled access, exercises that mirror real DevOps plus GenAI usage. 30 Days of AI Agents is a hands-on program designed to help learners understand, build, and evaluate modern AI agents using popular open-source frameworks. Over 4 weeks, participants will build AI agents using tools such as N8N, Crew AI, Llama Index, LangGraph, and small agents. Duration 30 days. Format live instructor-led sessions. Hands-on, yes, guided labs and exercises.
The first question for today is like, what is exactly the difference between a user space and a kernel space? And like I mentioned, I already have this diagram, and we can start with this diagram and I can just spoke about it, or we can try to draw this diagram together to understand what exactly is going on the user space versus the kernel space. So Abed said that user has the ability to do the task in user space. Yes, that is exactly correct. And what about the kernel space? So I will start with this, that user space is where the user application runs, right? It can be anything. Your user space application runs. Where the kernel deals with the memory and everything, yes. So it can be anything. Your browser, your Apache server, all those applications, they run on the user space. Okay. And then there is a kernel space where all the kernel space applications run. Right. So for example, like you guys have mentioned, like all the RAM and everything, all the management of those. For example, your RAM management, your IO process management, all those happen in the kernel space. Okay. Now, my next question to you guys, why do you think this kind of separation exists? Why can't we have everything running on the user space? Or why can we have everything runs on the kernel space? Why we have these two kind of a separation? So for example, if I want to run this Apache server here, or your browser or anything, why can't I just run it on the user space itself? Why do I need the kernel space? Yeah, some processes are hardware level. That is partially correct. I'm going to talk about the hardware level next. Yes, you are correct. Isolation is what I was looking for. So basically, think of it like this. So any rogue application or any code which is a badly written, they might going to impact your whole system. While in the kernel space, any code which goes, it's a properly vetted code. Okay. With that, it comes with a caveat that I am not saying that you don't see a hung in the kernel space or your system crash in the kernel space, but the chances are less. So it's just to provide an isolation as well as a security that a user space process cannot directly call the kernel. Sorry, what I mean to say, that's why this separation exists. You have a two different space, user space and a kernel space. Okay. Now, somebody talks about the hardware, right? So kernel is the only component which is present in your system which has a direct access to the hardware. And with the hardware, I mean the RAM, your CPU, your IO, all these space, that is managed by the kernel. So kernel is the only component which can talk to this hardware. So a user space process cannot directly access the hardware. It must need to go via the kernel. Okay. So kernel is the only component which can talk to the hardware, and we have this isolation. Now, my next question to you guys, how can kernel interact with the hardware? So I can give you an example. For example, let's say the hardware means your keyboard, your mouse. Okay, all the different components that we have talked about, the RAM and the CPU. there can be a n number of these component exist. So how can this translation exist? Like how can your kernel space can talk to this hardware? Is there any component which is involved or a layer which is involved which enables this communication between the kernel and the hardware? Yes, machine level language. Uh, I will say it's partially correct, Himanshu, but nice attempt. Yes, exactly. That's the word I was looking, drivers, which is called device drivers. So basically, device driver is a thin layer which enables the communication between this kernel and the hardware. So let me give you a simple example through which you can understand this part. So let's say I speak in English and there's a guy who speaks in German. So in order to enable a communication between me and that particular guy, we need a translator. And in terms of this whole thing, the device driver is that translator, which enables the communication between your kernel space and the hardware. So whatever the kernel is saying, device driver is going to translate, and that will be present to the hardware. Okay. Now, my next question to you guys, and I'm going to ask you guys a lot of questions while preparing this, because I want to develop the mental model, how all these things is going to work. Rather than we can memorize all these things, just try to think step by step. Okay. So in terms of drivers, okay, what exactly this is represented the kernel side. In kernel, you will say something else for the drivers, and we will say that kernel has all these device driver load. So in terms of Linux kernel, you will mark a different term for this. Did any one of you know what exactly is that term is? So we understand that device drivers perform the translation. But when you heard in terms of kernel, there is a specific term which we have used. Okay, I can write it down here. Those are called modules. So basically inside your kernel, there are a bunch of modules which has been loaded. Okay. And our kernel is modular. So basically, if the module is not present, you can install it on the top of it. Basically, all the kernel developers, they try to make the kernel as small as possible. So when your kernel loads, that is what we are going to see it next in the next question. It try to make it as small as possible. And these are loaded in the form of modules. But anyone knows like what is the command through which I can see what are the modules which has been loaded or present in my system? So my idea is I want to see all the modules which is present in my system. How can I check that? Okay, just in the interest of a time, is a command called ls mode. It's going to list out all the modules which is present in the system. Okay, and if you are not sure what exactly this module is doing, let's pick any of these, this IP tables. Okay, there's a command called mod info through which you can get more information about this particular module. Okay. So we draw our diagram till this far. So we have basically the user space where your application is running. We have this kernel space where all the kernel threads, or just in the simple terms, whatever the kernel application that is running. Then we have the device driver, which performs the translation. And then we have the hardware, which is the only component which can talk directly to the kernel. Okay. Now come back to this again, to this diagram. Now my question is, can a user space application, for example, this Apache server, can call directly to the kernel, or it need to go through some different interface? I will repeat my question again. So this user space application, this need to talk to the kernel. Okay. And when I say talk to the kernel, I mean, when you start any application, it requires some resources, right? It requires some RAM. It requires some CPU instructions. It requires some IO from disk. So can this user space application can directly talk to the kernel, or it requires something in between? So for example, if kernel need to talk to the hardware, it need a device driver. And we already spoke about like there is an isolation which happens. No, it's not shell. Yeah, that's correct. It cannot call directly, but yeah, David Leung has a right answer. Exactly. It's a system call. Yes. So system call is basically is going to perform the translation. So if user space process need to talk to the kernel, it goes via the system call. Now, again, my next question is who provides these system calls? We understand that user space process cannot directly talk to the kernel, but there should be some component which is present in the user space which can provide the system call, and that way a user space process can talk to the kernel. What is that? And I can give you the hint. After the kernel, that is the most important RPM or package that is installed in your system. If that package is gone, your system will be gone. So unfortunately, you guys are not right, but keep on trying. If you do RPM-QA and grep for one package called glibc. So after kernel, this is the most important package which is present in your system called glibc. And glibc stand for, let me type it here, GNU-C library. So once again, that's the wrong assumption that this package provides the system call. System call is provided by the kernel. This package provides the library, and those libraries have the function which can call those system calls. I can give you the simple example. Say this is a glibc package, and if you want to get more information about it, you can just type QI, and this will give you the information what exactly this package is doing. And you can read that glibc package provides the standard libraries. So I can give you the simple example with this one, ls command. So when this ls command execute, okay, it is giving you this output, right? That it lists all the file which is present on the directory, and under the hood, it makes all these system calls. Okay. So once again, your user space process is either Apache or it's ls. They don't need to understand all the complexity, what is involved in making those system calls. Your process just need to call the functions which is present on this GNU library, and it will call to the kernel space. Okay. So basically, like the driver who is doing the translation for this kernel, when it is communicating to the hardware, similarly, the system call is doing the same thing. It is performing the translation. Your Apache can call to the system call, okay, via this library, and that is going to make a call on the behalf of the user. Let me tell you one more example. Let's say you are running some command like cat, and cat command is basically read the content of the file, right? Let's say I run this command cat etc host, which is going to give me the list of all the IPs to the hostname mapping, right? Now, this cat under the hood calls something called read, right? To read a file, a system call it makes. So my cat command does not need to understand how this read system call works. It just needs to call this read system call using this glibc library and display the output of this host or whatever the file we are trying to read, uh, uh, and display the output to us. So basically, all the complexity is being taken care by this library. Okay, clear? So this is one of the most asked question, like what is the difference between a user space versus a kernel space? If you go to any of, for example, I can give you an example of any FANG-based company like Facebook, Google. This is the one of the question they usually ask. In their, they have a special section for the Linux kernel interview, and in that section they ask this question: can you explain the difference between the user space versus the kernel space? So now I will quickly summarize whatever we have discussed in the last 18 minutes or the 15 minutes. And then I want someone to take a lead and try to explain this in his own terms. Okay. So we will start with this user space where your application is running. And then we have the kernel space where all the kernel application or whatever the kernel code is running. Okay. And before I go there, let me show you. So for example, if you run the top command, you will see all the application which is running in my system. But you will see all these threads, right? Hey, workers, these. This is what we call a kernel thread. These are all the things which is running under the hood. Similarly, you have a command called slab top if you want to see all the kernel related things. I'm using a really loose language like things, but all the inode, the malloc allocation, all these, if you want to see, you can see it with the help of the slab top command, similar to top. Okay. So basically, we have this user space again where the user's application is running, and then we have this kernel where the kernel space application is running. In order to make a call from this user space to kernel space, we need a system call, and that system call is provided by the libraries. I haven't spoke about signals, but just forget about signals for the time being. We can discuss this later. And user going to be, your user space application going to use the libraries to make a system call to the kernel. And then kernel have this device drivers present, which is loaded in the form of a module. And those are going to allocate a resource for you, for your application. It can either be a RAM, it can either be a CPU or anything. Okay. So with this, we have done with the question 1